Hello, this is Miss Salter. This is going to be a very short video. This was some of the questions that were brought up about the notes in the induction lab in the survey that was given out. Some of the questions in that survey that people brought up, I addressed in the video about the problems from wait, because some people, oh yeah, that's right, because some people brought up questions about some of the practice problems that were in the examples that were in the notes. So some of those were also practice problems. So I posted a video about the practice problems. So you should be able to match that up. Some questions that were brought up on the surveys: how to solve for statics problems. Just like most of the other problems here in physics, these statics problems, we use model problems from our notes to understand which variables are used with which equations. That's the most important thing that you can figure out here in physics, is when to use which equation. So if we have two charges, you have to use the Coulomb's law equation with the constant in it. If you're just looking for a force, or if you're just looking for an electric field intensity, then you can just use the E equals F over Q equation that I have here underneath. Electric field problems use the equation E equals F divided by Q, where the electric field equals the force electric, kind of like our, tension force, mechanical force. It's our electric force divided by the charge of the particle. And then you can move that equation around how you need it. Don't forget, I did have someone bring up, like, what is this K value and everything? Sometimes when we get into these new topics, we have new constants or known values that are used in the new equations or scenarios. You have to look in the notes to find these things. You also have to look in the notes because we have something called elementary charges here, which is the known charge on a electron or a proton. That's given in the notes. You have to find that. So sometimes some of these problems will be like, okay, I want you to find the electric field of an electron given a force is so many newtons. Well, then you have to go back in your notes and find the charge of that electron. The Coulomb's constant, which is the K value, is a proportionality constant based on the medium surrounding the charges. So it's just one of these constants that actually trying to figure out where it came from and everything would be a very good sideline or something you may discuss in a further physics class. But for us, all we need to know is the value. And this one depends on the medium surrounding the charges. We've been all working with charges about air. So we use the 9 times 10 to the 9th because the charges that we're working with are in the air. Here in the induction lab, I went ahead and okay, I put in here some of my notes. Induction, we're moving electrons within the object, so we're not touching the object, we're using another object to shift the electrons inside that object. And then that's where we took the balloon and we put it near the object, or we put the plate near the board, near the pie plate, but they weren't touching. So we didn't have a transfer of electrons, we just had a movement, a migration of electrons from one part of the object to the other. So conduction then is when we did the actual touching of the thing, whether we touched it with a finger, as in the apprentice level, or we touched it with another pie tin or another item in the mastery level. That moved the electrons between the objects. So we were allowing the electrons to either escape or go into the object. So now this first set of notes here, I just broke down everything into its different steps. So this was where we had a neutral pi tin charged by induction. Step 1 was the polarization. It was near the positive board. The electrons in the pi tin moved toward the board. They were attracted to the opposite charge, the positive, on the board, which when we say the board is positively charged, it means that basically it has a deficit of electrons. Our protons are only found in the nucleus of the atoms. They don't move unless we do nuclear fission or fusion. It's the movement of the electrons. And this all goes back to chemistry. So if you don't understand anything in this unit, then you need to go back to some other reference that helps you understand the structure of atoms and that they are made of neutrons, protons, and electrons and what that means. There comes a point in time where we have to assume that you have a basic understanding of atomic structure so we can talk about statics. Step 2, we're charging, so while we're near the board, the pi tin is touched by the finger. If we move the pi tin away from the board, we no longer have the migration and the movement of those electrons, and they go back to being evenly spread throughout the pi tin. So while we're near the board, the electrons are moving toward the board in the pi tin. When we touch the pi tin with the finger, electrons from the finger move into the pi tin, and now it's charged, and the pi tin becomes negative. Just here at the bottom, I have some explanation here. During polarizations, the electrons move within the pi tin. Opposite charged objects attract, like charged objects repel, so the electrons in the pi tin move toward the positive board. The protons can't move because they're stuck in the nucleus. Electrons can't cross the air between the pi tin and the board. So the pi tin has different regions of charge, but it is still neutral. Then during the charging part, when the electrons move from the finger into the pi tin, they're attracted by the positive part of the pi tin. And therefore, then those move because there is contact. We just have attraction between the board and the pi tin because there is air. There's no actual movement of particles of electrons from one object to the other. And then I also included another one that had about the balloon and the metal ball. This one was the same exact thing. You bring a positive near to it, you get negatives attracted to the positive, you get this kind of migration, this localization of the charges. Then when you bring a negative thing in and you touch the positive part, more electrons move into that sphere, and therefore the sphere has a negative charge. Okay? Yep, and I hope this was helpful to clear up some of these ideas and misconceptions that were happened with the notes and the induction lab that were brought to my attention using the surveys. Thank you very much and have a good day.